现在开始广播，所有参与者都处于仅收听模式。
Good afternoon, everyone. I'm Vincent from Olympus Singapore. Maybe we can give everyone another 3 to 4 minutes so that we can allow other attendees to start joining. First, thank you everyone for taking time out of your precious busy schedule to come and understand a little bit more about this unique application that we are sharing today. So let's give everyone another 1 to 2 minutes before I start to discuss more about what is going on today and some of the rules during the actual presentation itself. Okay, without further ado, let us begin. So let me introduce myself first. Thank you everyone for joining this webinar. I'm Vincent from Olympus Singapore. So today we have invited Professor Chang from Taiwan University to share with us the application on heavy metals contamination in wastewater. Okay, so Professor Chang is from National Taiwan University, and he has held many leadership roles during his academic career in National Taiwan University, including department head, associate dean, principal investigator, advisory committee member of the Environmental Protection Administration, and council member for the Board of Soil and Groundwater Remediation Funds. His research institute includes water pollution control, soil remediation, and geographic information systems in natural resources management. So Professor Chang actually has a lot of experience in this field, and today he will touch a little bit more on what is going on in Taiwan, what are the cases that he has been facing recently, and how he managed to solve them. Okay. Today's agenda will be as follows. I will briefly go through the introduction, whereby I will explain a little bit about the theoretical part of XRF. Then Professor Chang will continue and discuss more about the hotspot screening, pollution source tracing, lastly, fingerprint feature construction. And at the end of the webinar, we will have some Q&A. So for everyone, just to let you guys know, if you have any questions, you can see on your dashboard, there is actually a questions tab. So if you do have any question, you can post your question in the tab. Then at the end of the webinar itself, we will go through the questions one by one with you guys. Okay. And throughout this whole webinar, we might be doing some polling. So there will be questions for you guys. Then I will appreciate if you guys can help me just answer the questions accordingly. Okay. So let me now start with the introduction. So basically, what is XRF and how does XRF work? So XRF stands for X-ray fluorescent. So what happened is X-ray will come out of the X-ray tube. It will interact with the innermost electron you will kick it out, and the electron nearest to it will replace the one that's being kicked out. So when this process happens, a unique fluorescent energy is given out, and our detector will actually capture this fluorescent energy. Then we will process it, then we will generate the result that you guys see over here. So it will have the elements present and also the concentration itself. Okay. So saying this, XRF technology is actually can be used to determine any chemical composition of any sample. So if you're interested to find out what are the elements present in your sample, this is a very good screening technology. Okay, so saying that there are many markets and applications that you can use it for. So like the scrap market, you can use to sort scrap metal. In oil and gas, they can use it for PMI to make sure they're using the correct pipings. You can use it for mining, for exploration, or even drill core analysis as well. You can use it for environmental purposes, academics and forensics, precious metal. You can use it to test your jewelry for the gold content. You can use to test for regulations for electronics and consumer goods. And lastly, we have a separate technology, XRD, X-ray diffraction for mineralogy. Okay. So some of the advantages of the XRF, number one, it is non-destructive. So it will not cause any damage to your sample. It is versatile and a rapid technique. So the sample prep is straightforward and the test time is typically 1 or 2 minutes, okay, or it could be even lesser. Okay, it is convenient and economical to use, so you can actually bring on site because it's portable and you are able to get a real-time data. Okay, the instruments have few moving parts, so it tends to be low maintenance. In terms of maintenance, you do not need to do a lot of servicing or alignment for the equipment. Okay, some of the disadvantages of the XRF, it has fairly high limits of detection when compared to other destructive methods. Okay, so what I mean by that is for the XRF, we're pretty much looking at ppm level or even very low ppm level, like maybe even 1 to 2 ppm. But for destructive methods, it can go up to ppb levels. So this is but however, the XRF is just a quick non-destructive testing compared to a destructive method. Okay, and there's also possibly matrix effect, which could be accounted for by using user calibration or software-based correction procedures. Okay, and it's also less suitable for liquid analysis. So today, Prof. Chang will actually be sharing with you guys how we can make use of his method and with the portable XRF to determine the heavy metal contents in wastewater, which we can actually easily pick up ppb levels as well. Okay, so before I pass the baton to Prof. Chang, I would like to start a poll right now. Okay, so I just want to have a quick understanding of all the participants over here. How many of you are existing XRF user? Okay, so probably take 5 seconds. I'll put it for probably 1 minute for everyone to start voting. Okay, another 10 seconds. Okay. Still quite a big chunk of you haven't voted. Okay, I'll leave it for another 5 seconds. Okay, thank you very much for voting. So it seems that it's almost a 50-50. Half of you are using XRF and half of you aren't. Okay, so now I'll pass it on to Prof. Chang to continue with the webinar. Prof. Chang, please.
Okay, next I will introduce a new device called TIRS, Time-Lapse Ion Exchange Resin Cassette. How this device can overcome the limitations just mentioned before. The resin cassette is made from ion exchange resin, which has shown ability to catch the ions in water in fast way. Besides, it's a homogeneous solid material. It has a huge capacity to absorb ions. After 5 or 7 days put in water, the heavy metals concentration in TIRS is about 100 to 1,000 times in water. So the TIRS-like concentrator, which can accumulate heavy metals from water on a homogeneous resin and become easy to analyze. In this way, make wastewater analysis possible by use portable XRF. Ion exchange resin is widely used in water purification, and there are several different types of anion and cation ion exchange resin. Here I want to emphasize it is a solid material with homogeneous composition, which can minimize the matrix effects. How to standardize the water flux differences? Because TIRS is not in a confined space, therefore the amount of water passed through each cassette is unknown. In natural water, the concentration of strontium and the calcium in a specific area are relatively stable. For example, the calcium concentration is 25 milligram per liter in Taoyuan, northern Taiwan, and 60 milligram per liter in central Taiwan. So therefore, the ratio of metal to strontium can be used as an indicator to eliminate the influence of different water flux. For example, although the copper reading in site B is greater than site A, but they have different flux. After standardization, the concentration of site A is greater than site B actually. If you want to know more about the details, please to read our journal papers. Taiwan's soil pollution investigation has been conducted for more than 30 years. The location and the spatial distribution of the pollution has been very clear. They are in Taoyuan area of northern Taiwan and in Zhanghua area of central Taiwan. Their common feature is that the land use pattern in the inner range are very complicated. There are a lot of factories in the farmland, as you can see in the aerial photo. If we look at the problem of soil pollution, it is mainly due to the pollution of irrigation water. That carries heavy metals into the paddy fields and cause soil pollution. 25,000 cubic meters of waters is applied to 1 hectare of paddy field annually. Therefore, the area where irrigation water is polluted are very consistent with the area where the soil is polluted. In Taiwan, everyone has known this problem for a long time, but there's no way to solve this problem. The main difficulty is that there's no quick and economical way to monitor heavy metals in water. Because illegal emissions are done during late light, holidays, or heavy rains, it is not easy to obtain evidence of crime, thus causing people to lose confidence in government's ability to enforce law. How to assemble the tiers when the resin facade is ready? We use a plastic net on the outer layer to protect the resin facade. We also put a glass bead inside the lab to increase its weight to ensure that it can be submerged in water. We will also use fishing line as a tester. Deploying tiers inside according to the factory distribution and the irrigation pattern. Okay, hard pass screening. Now we use the actual case in Zhanghua area to show you how to do the hard pass screening in a large area. We divide it into several small portions according to irrigation range and place a lot of tiers in each small area. After 7 days, we took these tiers back to laboratory and dried them for XRF inspection. As mentioned earlier, we standardized these measurements results by ratios of metal to strontium. Here we have copper, zinc, and nickel ratio for each point. If the value greater than mean plus 2 standard deviation, point out the hot spot. In this way, the hot spot can be clearly marked. And also know which kind of heavy metal is too high. If we trace the direction of irrigation water flow, we can clearly identify where the problem occurred between 2 points. The second application example is how to trace the source of pollution and find the culprit. As you can see in aerial photo, the complexity land use status in Taoyuan. When we find that the concentration of heavy metals in sediments of channel in the downstream area was very, very high. But in the upstream area, because the channel were covered, it is difficult to find out which factory discharged the pollutants. In this picture, we can see that we have placed a large number of tiers along the channel and the bench canal. Okay, here on this picture, you can see that the green dot indicate that there's no problem, and the yellow asterisk are the points where heavy metal are abnormally high. In this way, we can identify who is the culprit. Because these successful stories are very exciting, so the newspaper, TV, and magazine report the story. Hope you can understand Chinese. Fingerprint feature construction. How we can use this new math technique to create fingerprint for factory wastewater in industry park. Because XRF detection can simultaneously provide 15 to 20 elemental composition in sample, which provide a unique feature as fingerprint of a specific factory. There are 361 factories in Guanyin Industrial Park in Taoyuan. It is a comprehensive industrial park with various types of industries such as electric plating, PCB, petrochemical, paper, textile. And there is a joint wastewater treatment plant with capacity of 56,000 CMD. Every factory was asked for doing pre-treatment before discharge. Treatment fee is based on the quantity and the quality of wastewater. However, the data provided by factories are often incorrect, but it is difficult to verify because the quality of these discharge waters changes at times. We carry out this plan. We did not go into the factories to take samples. Instead, we put tiers at manhole where the wastewater discharge comes out from the factory. And after the data correction, huge amount of data, and we can do some data analysis by principal component analysis. And also we can list the top 20 factories of metal emission in wastewater in this industrial park. And we can do verification. Here we find some false declaration by factors because we have reading a lot of arsen, lead, zinc, copper, nickel, but the report is 0. After the experience in Taiwan, and here we can make some conclusions. Cumulative average solute concentration over a long period of time get better representative samples. Safe sample handling, because no power supply and chemical required on site. Easy to transport and store samples. We don't need a refrigerate and any other equipment to transport or store the samples. Simple on-site procedure can greatly save time and manpower and adapt to various water environments. That's for today's lesson. Hope you can learn something from my sharing and any question from audience.
Thank you very much, Prof. Chang. So, guys, just to do a quick summary as well. So, Prof. Chang actually has shared a very unique and special method that he has developed with some of his fellow colleagues. So just now you were able to see that they have actually published some papers on this technique as well. So if you want more information about it, we can share the slides and also the papers with you guys so that you can understand a bit further. So with this tiers itself, now you are able to pinpoint exactly where the pollution is coming from and which factory is it coming from. Then also for waste treatment companies as well, this will be a quick indication for you guys as well that you can use this method and not directly testing the water as well. So with this technology itself, you can quickly use the resin to absorb the heavy metals. Then through our special calibration, you'll be able to determine what is the heavy metal content in the wastewater itself. And with the resin itself, we can actually collect and accumulate heavy metals. So that is whereby we can even measure up to ppb levels after back calculating the concentration. Okay, so with that, do you guys have any, if you guys have any questions, as I mentioned just now, please go to the question tab, then key in your question and send it to all so that I can take a look and we can ask Prof. Chang about it. So we have one question here, Prof. So asking how many days should we immerse the sample in water?
It depends the flow velocity because the ion exchange resin has capacity. So in our experience, 5 days to 7 days is okay. Before it's full, I mean the capacity is full.
Yeah, so with the special resin that Prof. Chang has actually developed and chosen, it has a greater capacity compared to the previous one. So that's why putting it in water for 5 to 7 days is actually okay. And actually, to be honest with you guys, putting it longer is actually more representative of the actual pollution that you are getting. Because if you were to just put it for 1 day, during that period of time, no one might be even discharging any wastewater. So by putting it through a slightly longer period of time, 5 to 7 days, definitely within 1 week, someone will need to discharge the wastewater. And if they are discharging wastewater with heavy metal contents, then we will be able to capture it.
Yes,
Okay.
because most illegal discharge are not continual. So we put in 5 days or 7 days, and it's easy to cap this behavior.
Okay. Second question, what are the difference pXRF and EDXRF? Okay, let me answer this question. So pXRF actually just stands for portable XRF, meaning to say it's a handheld device. The pXRF that we're using right now, the Vanta, is actually using EDXRF. Okay, so XRF technology itself comes with 2 different types of method. One is the energy dispersive XRF, which is the EDXRF, and the other one is the wave dispersive XRF. So for the technology that we're sharing today is actually using the EDXRF. But in the market, we call it pXRF because the P actually stands for portable. so that you can bring on site to do the testing. Okay, so we have one more question: how to obtain tiers commercially? Okay, so for this, we will need to talk to an Olympus representative. Then we can actually discuss this further with you guys. Okay.
Yes.
Are there chances that factories can manipulate data? 教授，他们是说有没有工厂会不会伪造数据？
That's for sure. They will do that.
So Prof. Chang was saying that it is common that factories will actually manipulate data. They will change the data. But this is whereby if we are using the resin, like what Prof. Chang shared in the previous slide. Let me go back to this one to share with you guys. Okay. So over here, this is a very good example. So the factory has actually declared that there are no heavy metals in their wastewater. However, through the monitoring process, we are able to determine that there are heavy metals such as nickel, zinc, and a little bit of copper. Yeah, so by doing this monitoring, we can actually tell the customer that, hey, you're actually lying, and you need to pay for what you have discharged. Okay, so this is one of the purpose of this method as well.
Yes.
So another question, Prof. In order to get the right result, we also have to use other method to analyze them, put the result in the table for finding the K factor, right?
Yes. Pardon me?
Sorry, can you try? I think the question is a little okay. So he's saying that to get the right result, we have to use other methods such as AAS or ICP to analyze. Okay, so what he's trying to say is we will still need to correlate with other methods to find the factor. So Prof. Chang, are you using other methods to verify the concentration as well, like ICP?
Yes. In our country's regulation, the official report should be analyzed by ICP or AA, but that has very limitation because it takes time, it's expensive, and also the sample is not representative as for a long period of time as tiers.
Yes. So for the tiers itself, Prof. Chang and his team actually spent quite a lot of time building a calibration itself for the XRF. So he also used ICP and AAS result to build his calibration, so that it will be so that you can use the P portable XRF on the field to get a quick screening of the result itself. So that's the whole purpose of the equipment. But like what Prof. Chang has mentioned, ultimately, if it comes to the final enforcement stage, they will still need to put through it through AAS or ICP. Okay. Can you explain on the disadvantage that XRF is less suitable for liquid analysis?
I mean, if we use a low-end portable XRF, it's less suitable for liquid samples.
So for the liquid sample itself, it actually depends a lot on the homogeneity of the liquid. Because as you guys know, when we come about XRF, the most important thing is homogeneity. So sometimes if your liquid contains some PPT or particles and it's not homogeneous, in the end, your XRF data might be just testing the subsurface of the liquid, and it won't be representing of the whole entire liquid itself. So that's why by using this resin method, we are able to use the resin to absorb all the heavy metals. Then we measure the resin itself, so that it will be more representative of the liquids, the wastewater sample. Okay. How to ensure that sample is homogeneous?
Yes, we analyze 4 or 5 times at the different point of the resin success. And this gives us the confidence that the reading almost the same. So I think it is homogeneous.
Yeah. Yeah. So Prof.
I mean the heavy metal concentrations is evenly distributed on the surface of resin.
Thank you, Prof. So have you seen any differences in the efficacy of the method with variations in wastewater, non-metalloid compositions?
Pardon me?
是说它有时候你会不会觉得有时它不是重金属的含量
Yes, for most cases, the richest ion in water is sodium and the calcium and the potassium. So as you can read some data on the here, you can see the calcium concentration is maybe 1,000 times higher than other heavy metals.
So Paul, does it actually answer your question? Give me a second now. There are a lot of questions over here. So then we. Okay, so Prof, we got another question. So as mentioned, pXRF is not suitable for liquid sample. So how then we want to measure the pollution? Do you have to treat the sample before analyzing it? And do you need other reagent to use with the XRF?
After pick up the tears, we only wash it by pure water and drying it in an oven about 60 degrees. Then they are ready for analyze. We didn't need any other chemicals.
Yeah, so to measure the pollution itself, we just put in the tears, let it absorb for 5 to 7 days, then we'll bring it up, and we will actually simply just dry it. It can be air dry, or you can use the oven as well, but air drying takes longer time. So normally we will try to use the oven to speed up the drying process. Then we will analyze it with the XRF. So to answer the question, you don't really need any other reagent. You just need the resin itself to test the sample. Okay. So there are cation and anion type. So Prof, can you explain a little bit about this, the cation and anion type of resin?
Okay, if we use the standard solution, usually for AA and ICP, they are made from chemical only contain positive charged metals. But in the actual situation, many industry, there are different background on the water. So the metals can be in negative charge. Although for example, the Cr2O7 is -2 charge, so it will not be absorbed by cation resin. Instead, it will be absorbed by anion resin. So we need two different types of resin to ensure all the dissolved components can be captured in a resin.
Okay, thank you, Prof. How are the sampling locations selected to obtain a representative sample?
Actually, because the tiers is not expensive and is small, so we can put a large amount of this device. And the XRF measurement is quick. So any in situ status, I think everyone in a specific area will find something is abnormal, so they can put the tiers.
So I think is normally what we do is, I think first we need to find out how is the irrigation flow, etc. How is the canal flowing? Then how can we segregate it out between different factories in the induction park? So once we have the map, then we will identify spots that we want to place the tiers so that we can make use of this data to verify that whether the wastewater is coming from factory A, B, C, or D. Okay, then to make a representative sample, like what Prof has mentioned, the tiers is not very expensive, so we can probably put like 2 to 3 of them at maybe a few meters apart, so that we can have so that once we collect back, every point we probably can have like 3 data just to confirm how the heavy metals in the wastewater. Okay.
Yes, we can put the tiers in rivers, in irrigation channels, in ditch, everywhere.
So regards to pollution sources tracing, is this spot sampling or can be recorded for a certain period of time on a 24-hour basis perhaps, or during night time perhaps, where most of the facility discharge their wastewater? I think the tiers itself, what happened is you can actually, I think that's the, for now we are not really targeting to find out at what period of time is the discharge of the wastewater. For now is we are trying to figure out which factory is responsible for the discharge. That is whereby we are putting the tiers for at least 5 to 7 days, so that we can get accurate result and make sure that factory A is really the one that has been discharging. Right, Prof?
Yes. Usually we put the tiers for 5 or 7 days. If it's abnormal, then we will increase the frequency down to the 1 day or even less. And at that, we use the pH and the EC meter to record the variation, so we can understand the behavior of the illegal discharge.
Yes. Prof, what is the level of confidence, accuracy % of the instrument?
We, for most cases here today, we only not for very, quantitative analysis. Actually, we have to do some comparison with AA and ICP when we use a controlled volume of water, like 1 liter or 2 liter, and prepare from the laboratory with the known concentration. Then we react with the tears after maybe 2 hours, and we analyze the residues in the water by AA or ICP. There's no anything left in the water. So we understand all the ions, heavy metal captured by the tears. In this way, we can do very well correlation with the AA and the ICP.
Yeah, so as we mentioned just now, we actually did some calibration comparing with the AAS or the ICP. So the calibration that is using in the XRF is actually being calibrated based on what Prof. Chang has actually done in his laboratory. Okay, so out in the field, the XRF will be the perfect tool to give you an understanding on the spot on how is the levels of heavy metals in the wastewater. But like what Prof. Chang shared just now, ultimately when it comes to the enforcement stage itself, they will need to send the sample as well to AAS and ICP to get the final report. Right, Prof?
Right.
So what is the range analysis? In case of high concentration, how the instrument behave?
I think it's a characteristic of the XRF. It can simultaneously measure the major elements and the trace element. Just you can see in this figure, we can read calcium in almost 60,000, and the other element maybe in 2 or 2,000.
Yeah, so the XRF actually provides limits of detection from low ppm to actually even like percentage level. Okay.
Yes. This is why everybody likes to use the XRF.
Yes. Okay, I think there has been a lot of question over here asking for soil environmental testing. So Prof, do you have any experience in this as well for soil environmental testing?
Soil is a solid material, so it's already very common in use by XRF in our country. The challenge is the water sample, because the concentration is very low and the water is a liquid with heterogeneous composition.
Yeah, so just to share a little bit with everyone, as Prof has mentioned, for handheld XRF, it has been already commonly used in many countries by the EPA itself for soil environmental testing. So you can actually directly use the XRF to test on the soil samples itself to find out what are the contamination or what are the elemental concentration that you are looking at. Okay. What are the techniques to rectify the interference during sample analysis?
There's no matrix effects because the ion exchange resin is very homogeneous, and it's a industry product. So it's not like the soil or rock.
Mm.
So get the very good results.
Okay. So thank you, Prof. So I think a lot of people has been asking about the slide sharing. So don't worry, after the session, we will actually share the slides with you guys through the emails that we have from all the registration. Then we also try to share some of the publication that has been done by Prof. Chang as well. Okay. Then if you have any question regarding the equipment and the course itself, we can actually talk to a Olympus representative in your country. Okay. I see that we don't have any question now. So before I end the session itself, I would like to do one last poll. Okay. So the last poll is actually whether do you guys wish to be contacted for a demo. So I'm seeing that a lot of you guys are interested to find out what is the course and what is the application like. So over here, if you are interested, please select yes. Then we will contact you after the webinar itself. Okay. At the same time, maybe last minute, anyone have any more questions that you want to share with us? Okay, now only around 50% have voted. Okay, if not, thank you everyone for attending the session today. And thank you very much to Prof. Chang for taking time out to do this webinar with us. Okay, thank you everyone. Have a good day ahead. See you guys. Bye-bye.
Bye-bye.